Hey, everybody, welcome back to another edition of the Security Repo Podcast. Great to have you here. As always, I'm your host, Dwayne, and we really appreciate the likes and subscribes. We've been going up recently, and it's really helping the channel grow and get the message of security out there to the wider world. And we're just very happy to have you on this journey with us. This week, we have a really awesome guest, Matt Olmsted, who's worked professionally in software engineering for over a decade, and he's been interested in InfoSec for his entire career. In 2024, he decided to go for the CISSP, that's the CISSP, as his first InfoSec cert and passed the exam at the minimum number of questions after only studying for 2 weeks. He's something of a polymath and renaissance man, literally, and later, in both the literal and figurative sense, he's going to prove that to us. But welcome to the show, Matt.
Happy to be here. Looking forward to the conversation we're going to have.
Well, it's great to have you. I met you down at B-Side San Diego this year. That was a really awesome event. I highly recommend if you're in the San Diego area or in Southern California area, plan on going to that next year. But they had a first-time speaker track, and that's where I met you. You gave a really awesome talk on cryptographic basics. What was that experience like for you?
It was a lot of fun. I was fortunate in that, well, how to put it, it was difficult to try and squeeze all the material into the 20-minute time block that I had for the talk, but managed to do it just barely. But it was a good time, and I had a great time doing the talk. And I actually, because of doing that talk at B-Sides, a friend of mine invited me to give the talk to his applied cryptography class, if memory serves.
Oh, that's awesome. That is the typical experience for a speaker. Like you do that, break the ice, you're first in, and then either it's like, this was not for me, I'm not going to do this again, or you catch the bug and it's like, well, where can I speak next? It sounds like you caught the bug.
You might say that amusingly, kind of preemptively, because 2 weeks before B-Sides happened, there's a local DEF CON group near me, and I presented a different talk about cascading Bloom filters and a really cool usage of those that Mozilla came up with to fix certificate revocation.
Let's step back for a second because I do want to talk a little bit about what you presented at that B-side. So without
Yes.
going through the whole talk, why this topic? So maybe you could say a little bit about what you talked about and then like, why'd you get interested in that?
Sure. So the topic was understanding cryptographic primitives was the official title, you could say. And the reason I did that talk was in part because I had kind of already done the talk before at a previous employer of mine. I came up with the talk as a lunch and learn session that we did there. Fast forward a few years to last year, and I was told that B-Sides was looking for talks that would cover introductory topics. And so I thought, well, something that covers the basics of cryptography and cryptographic primitives would be a good thing that would fit that. And I had multiple people after mentioning that work talk say that I should try giving a talk at a conference. So the talk covers your basic cryptographic primitives. So you've got cryptographic hashes, symmetric ciphers, asymmetric ciphers, and digital signatures, I would say, are the big 4 buckets.
Right on. So why do you think we in security need to understand these primitives?
The way that I would look at it is taking even more like a more general look at things. There's always going to be fundamentals in any field that are going to help you with understanding core concepts. So if you understand the fundamentals, you can then use those fundamentals to work your way up to more complex topics. So when you're talking about cryptographic primitives, if you understand hashing, digital signatures, that alone helps you with understanding systems that use these things. So if you understand these cryptographic primitives, you can open up your browser, take a look at a certificate, and start understanding what's going on. You see the signature for the CA that signed that certificate, and you're able to go and verify it yourself if you wish. That's part of the cool thing about cryptography is all this stuff is in the open. It's understandable. There's no magic. It's just math.
Right on. So this is definitely, I can see it applied like the SSL side of the world and, set up MTLS. But broader than that, like from a first principles perspective, like how does this help on like the blue team outside of like, I looked at the browser, like how could I use this as a blue teamer?
So one way that I could see this being used as a blue teamer is, first of all, just for verification. Like if you want to make sure that you're verifying that your certificates are what they should be, you can straight up run, making sure that the signatures match up and that the thumbprints are correct. Another thing would be, let's see here, for if you're validating the promises of a particular vendor, if you understand how these primitives work and they say, oh, it's military grade encryption, et cetera, you can look through that to the more technical details and say, okay, are they actually providing the guarantees that they should be and using a technology that actually makes sense? If someone says, which, this is hearkening to current events right now, oh, it's got Bitcoin level encryption. Well, what does that actually mean? The Bitcoin blockchain is really just a chain of hashes that, fit a particular criterion for the mining difficulty. And so, the only encryption really you could say is dealing with the signatures for a wallet to, engage in some transaction.
Right on. And I don't think you went into it again for lack of time because you covered a lot in that session. Uh,
Yeah.
so this gets into the world of like where we came from, like starting with you started way back at the beginning of time. You think you started with Caesar ciphers or something like that, right?
Yeah. Yeah. It's just like a toy example that's easy to understand.
But now we're talking posting post quantum encryption. I hear that term thrown around a lot, and
Mhm.
I just love your hot take. Like, what does that even mean?
So the way that I would look at that is post-quantum algorithms are those that are designed to be difficult to break by quantum computers. So one example would be there's a post-quantum version of Diffie-Hellman. So that's your public key exchange to agree on a shared secret. Now, if I'm not mistaken, I think it was that my understanding of the weaknesses to quantum computers is primarily for things like your public key cryptography. So public private key crypto, when you're talking about RSA, it really comes down to you're multiplying two gigantically huge prime numbers together, and the difficulty of finding which two prime numbers were multiplied is what gives it its cryptographic strength. So I believe that that is one of the potential attack targets of quantum computers, is being able to reverse that prime factorization easier. I'm not as familiar on the specifics of how far along that is. The last update I heard about quantum computers reversing prime number multiplication was the number 35, I think. So, factors of 5 and 7. But I'm pretty sure it's farther along at this point.
Just to be clear, we're not talking 35 character numbers. Like that's a pretty big number. If you got one followed by 34 zeros, that's a pretty long number. You're talking like
Yeah, we are
literally the
talking
number 35.
literally. Yes, exactly. The number 35, so you're talking, what, seven's 3 bits? Let me think here. As I do this in my head. Yeah, 3 bits, 1 and 2, yeah, 1, 2, and 4. So 3 bits for that, and then you've got 5 is 2 bits. So yeah, you're talking very small numbers. Again, I think I heard about that last year or the year before, so I'm pretty sure things are farther along since, but we're still in the very nascent stages of this quantum computer funness we've got going on.
So I mean, you covered everything there from like the beginning of time to like what we're doing next
Yes.
with this stuff. How did you get interested in this? Like, why this area of study?
Just so for when it comes to giving the talk, that was just because I had already done a topic very similar to what I did at the conference, and it's a subject that interests me. And I figured it's a good way to get people into security because when you demystify terms like encryption, it's not as intimidating to go into it. I mean, if you understand the expectations and the purposes of, say, like where you would use a symmetric cipher versus an asymmetric cipher, where hashes are useful and where a digital signature might make sense, it just makes it that much easier to reason about and think about. Because once you understand those concepts, you then have building blocks that you can, assemble in your head to create larger systems.
So since I got you on the show and you've been studying this for a while, I do actually have a real question, and hopefully this will be helpful for other folks out there. Like, when should I use symmetric keys versus asymmetric keys? Like, asymmetric keys make total sense to my brain that
Mhm.
we do the math and we end up with the Diffie-Hellman situation, but symmetric keys, like, what's the use case for that?
Bulk encryption. Symmetric ciphers are way faster than asymmetric ciphers to a ridiculous extent. So, take for instance your web browser when you open up a connection to a website. So, first of all, you're going to get the certificate for the website. Your browser's going to make sure that those signatures all validate that, the website is who they're claiming to be. And then you're going to do that key exchange. Now, what that's going to be doing is agreeing on a symmetric cipher key that you're then going to be using for your communications going forward from there.
I gotta ask, is this like your day job? How does this impact your day-to-day work? Are you working on encryption things like at this level, at the primitive level, or like what level is this applied to in your day-to-day?
How to put it? I would say it more applies to my day to day and understanding the underlying mechanics of systems. So I work as a software engineer. So if I'm dealing with authentication or the like, I'm making use of APIs that abstract away a lot of those nitty gritty details. But it certainly helps to know still how to correctly use primitives if, say, you wanted to build your own system. Granted, I would also say another point that I'd like to mention that I have in my talk is don't roll your own crypto for any production use case. It's just a bad idea. There are so many ways to get it wrong. It's ridiculous. There are side channel attacks that you might not know exist. One of my favorite examples that I'm aware of is some researchers at a university found out that if you measured the electrical potential of touching a device that's performing cryptographic operations, you could derive the cryptographic keys based on that.
What?
Or another fun example was one where scientists took, I think it was 60 hertz video, but through some clever trickery, they gave themselves resolution of 60,000 hertz. And they were able to extract cryptographic keys from a device hooked to an AC adapter that had an indicator light on it based on the fluctuations in the LED.
That's wild. I mean that
Yeah,
that's wild for in a lab, but when you think of the real world implications of what you could do with that, like that's a nightmare for operational technology because like
yeah,
how do you update those systems? You go plug something in and then based on how it's updating, you saying you could like derive the secrets out of that.
yeah. If I'm remembering correctly, that particular study, the scientists were getting it out of an iPhone that was connected to its charger.
That's completely wild. I mean, I guess at the end of the
Yeah,
day, it kind of makes sense because we're just bouncing numbers off or light off silicon at the end of the day. We should be able to derive pretty much anything off of the electrical signals. Like that's really all
well,
the computer's
well,
doing anyway, right?
true, but there are ways around that. So the reason that you can derive a key like that is because what the computer physically does as it processes those bits differs based on the key. So if you can, and this is something that, as far as I'm aware, does exist, is that you can write your encryption scheme in such a way that regardless of what the key input is, it's still going to perform the exact same operations. In which case, you would not get that variability that would let you extract a key. But that's also very difficult to do, especially when you keep in mind things like you're actually going to be working against compiler optimizations with that. Because compilers, they always want to make things run as efficiently and fast as possible. And sometimes to get constant time operations like that, you have to actually disable certain optimizations there.
I do want to go back to something you said earlier, and I introduced you as a software engineer,
Mm-hmm.
and then we had this whole conversation about security. You got your CISSP last year, or
Yes.
CISSP. Um, what inspired you to go do that? Is this like a long term career decision, or just like you're just interested? Is like you already knew this stuff? What
It was
why?
partly to be able to have something official on my resume besides being able to put down, hey, I enjoy topics of security and trying to apply to security focused organizations when I was on the job search last year. So it was, again, being able to have that credential there. And it was an interesting experience too, because I was able to actually say, okay, yeah, I have gone out and actually gotten one of those certifications and dealt with the studying for it. Um, with you mentioning, getting the bug for doing talks, one that I may end up doing is going over the strategies I used to pass that exam.
Well, I can only imagine that having a background in engineering, like real world, actual doing it as a job, engineering had to have helped with that.
It did to a point. So the CISSP in particular, it's also a management certification as well as having technical understanding. So the parts that I related to study personally was more the what you would call getting a manager mindset for how you approach those questions. Because yes, there are questions where you could answer it going into the technical solution to some particular problem, but when you're talking about working at a business or some organization and trying to how to put it, solve the problem in the future as well, you're usually not just looking at the technical solution, but actually changing the policy of the organization itself.
Yeah, change management is hard. So understanding how
Yes.
to approach that problem is really clutch. Uh, Thanks so much for being here. We like to ask all of our guests a few standardized questions to get a sense of who you are and how you think out there. So let's just dive into that real quick. So
Sure.
the first one is, what is your favorite command line security tool, or your favorite security command line tool?
I would say fail to ban, just because it's so stinking useful to use as for hardening a server. And recently, I learned of a fun new way to use it. Actually, so there was a study done where, again, I'd have to double check the exact details here, but my understanding is that when a new website goes on the internet, within the first few minutes, there are already attackers trying to scout out something that they can take advantage of, well before any legitimate users would likely find it or be directed to it. And one of the things that they search for that you can use as a nice little, how to put it, heuristic is they will look for a .git directory. Now, if your website has no reason to be hosting a Git repo, then if you just create a rule where any website that tries to look for a .git on anywhere on your website's directory tree, that alone is going to make a huge difference in cutting down on people attacking your site.
Absolutely. There was a report a couple of years ago, like they found like 2.4 million .git folders. UN websites were notorious for this. Like they just had a .git folder, and unfortunately, in a lot of those Git folders are credentials. Like people are like, well, that's where I'm
Oh,
storing
yep.
my profile. Because if you use a proper Git workflow, that situation should never happen. That .git folder should never end up anywhere. But especially old servers, that's just FTP the whole thing, and that's how we end up in that situation. That's actually a really clever use of a tool. You said that's fail to ban.
Yeah, fail to ban. Uh,
Okay,
the
that's new to
word
me. I've not
fail,
heard that
number
one.
two, and then ban.
Well, thank you. That's a new one for me. I think that's a new one for a few of our audience members, maybe.
That one's a great little tool. Like, I think some of the default rules are like it will automatically block IPs based on failed authentication attempts. And then there's a number of various rules and whatnot you can configure in there as well. So great little thing.
So next up, you've had a number of jobs and you've interviewed for a number of positions over your career. Do you have like a favorite question you've ever been asked in an interview?
I can at least say one anecdote I really enjoyed from my hiring manager for my position that I'm at currently, actually, is he asked a question which was relatively simple, but the way that we wound up actually going into the solution was a lot of fun. So he was the only interviewer I've had where he actually encouraged me to use an LLM tool in my code editor when we were going through solving the problem. And it was a relatively simple issue where you have a JavaScript function that's making requests, and you have a randomized timer for when those requests might come back. So what he wanted was to preserve the order of the request going out for showing the response that would be coming back in, but to still keep the same sequence. So one example I would give here is, let's say response one or request one goes out and it comes back right away. Response two goes out and let's say it takes 2 seconds, and request three only takes 1 second. So the idea would be showing the response from three only after the response comes back from two. So it's just a fun little exercise in asynchronous programming. And it was also fun because since he encouraged using, existing tool sets that are out there, as far as like using an LLM to help come up with the answer and, come up with a solution, we actually had a little fun during that interview experimenting and seeing how the LLM handled it.
Well, don't leave us in suspense. How did the LLM handle it?
Better than I expected, actually. So it actually came up with a pretty good solution that, if I'm remembering correctly, wasn't as straightforward as it could have been. And so, we basically ended up cleaning up one of the solutions it had, and then that did the job that was needed. I think it was making use of a reduce call that wasn't really necessary at one point.
All right. Best advice, worst advice. What is the best security advice you have ever heard or ever given?
I mean, if we're going to go just from a practicality standpoint, keep your stuff updated. Being unpatched is one of the easiest ways to end up getting yourself exploited in some way.
I like the way you framed that as keep your stuff updated, like as a personal level. I'm a
Yeah.
firm believer in that. Like I will stop in the middle of meetings, like, hey, I'll be right back, and just update Chrome right then and there because there's a reason they push that update.
Oh, yeah. Especially if there's some sort of 0 day out in the wild. I mean, I think the last update that came out from Windows had how many criticals? And, I think there was at least one or several 0 days or, found in the wild exploits.
Oh yeah, I mean, if you're running Windows, yeah, definitely keep everything up to date. Get those security patch Tuesdays in your blood. And what's the worst security device you're hearing floating around out there? You're something like, why are they saying that?
I feel like one of the worst ones I've heard is people just trying to act like a virus, antivirus is the only thing you need because it's not going to do it. And honestly, these days, compared to say, Windows Defender can actually give you more issues than it solves, just because of all the weird tricks that they pull to get their shim into the OS to intercept things.
Yeah, um, antiviruses have their place, and there definitely is a world they help in. But yeah, you're right. Defenders. We'll just leave it at that for that one. Um, so I did have another topic I wanted to bring up with you, and that is you are a known ocarina player, and I don't know any other ocarina players. You're the first one I've ever met, and you have prepared a little number for us. Is that correct?
That is correct. And actually, tangentially on the ocarina topic, the way that I've gotten my music out there primarily has been through what's called the Podcasting 2.0 initiative and Value for Value Music, where there's some new features that have been added to podcasting that are supported by newer applications, including being able to stream micropayments while you're listening to a show based on the time that you spend, or people being able to send what effectively are like cross-platform boostergrams cross-platform super chats called boostergrams. And so the way I've published my music is actually literally through putting up an RSS feed like a podcast.
That was awesome, man. That was great. That's a first on this program. We have never had anyone perform. We've had other people that are musicians. We have Nerdcore rapper on once, but she didn't perform. So thank you very much. That's a first for the show. That's awesome. So we're here at the end. This has been a really interesting conversation today and a really interesting episode. We always like to give our guests the final say. If there's anything you want to plug, anything you wanted to make sure our audience walks away with, the floor is yours.
Well, if I'm going to plug myself, my website is mattthetall.site. Doesn't exactly translate over the wire, but I'm 6'10". Although my go-to response when people ask how tall I am is 5'22", because may as well have fun with it. Say one thing that, probably any security show should end with, it's patch your crap. Yeah, I don't feel like I have a huge amount to add offhand, but then again, I was also just focused on, playing music, so my brain's is still a little bit out of it from that.
No, man, that's a great note to go out on, pun intended. Thank you for being here. And everybody out there, please like, subscribe, share this with your friends, especially this groundbreaking episode where we actually had some musical guests. So thank you.